we're gonna learn about what a logarithmic function is. There it goes. We're gonna talk about changing exponential to logarithmic and logarithmic back to exponential. We're gonna learn how to evaluate a logarithmic expression, determine the domain of it, graph them, and solve. We'll graph the functions and solve equations. Remember, I told y'all right throughout the whole semester that domain was basically we were using the same process for all domains all the time. This is where it changes. For logarithmic functions, the domain's a little bit special. And so we're going to talk about that probably, well, we might not get that today, but maybe tomorrow. So let's talk about why do we have logarithmic functions? Why do we have logarithms in the first place? Well, if we had a function, we're going to use a simple exponential function, right? F of x is equal to 3 raised to x. And we want to find the inverse of that. And we know that we can find the inverse because if you remember, your exponential function is either exponential growth or exponential decay. So they're either always increasing or always decreasing. So they are one-to-one. Exponential functions are one-to-one. And so if we want to figure out what the inverse is, well, we're going to follow our process. We're going to say y is equal to 3 raised to x. We're going to replace f of x with y. And then to find the inverse, what do we do next? Anybody remember? We swap the x's into y. So we're going to have x is equal to 3 raised to the y. And then what do we do? Anybody remember? We're going to solve for y. Yeah. But how are we going to solve that for y? The way that we learn to solve those exponential equations was to get them with the same base, but I can't get x and base with a base of 3 raised to the power. I don't know what x is. And so that is why we need logarithmic functions. We need some function that is the inverse of an exponential function because we don't know how to solve for this. That's the whole reason why. So a lot of the terms, the vocabulary that we've been using, the base, stuff like that, that's going to stay the same because logarithmic functions and exponential functions are related. So the logarithmic function with base a, where a is greater than 0. So once again, we have those, well, the same term of base a. Remember when we had exponentials, we had that base. And we said the base had to be greater than 0 and it couldn't equal 1. Same situation here. So it has that shared property with the exponential function. We denote that by y is equal to log base a of x. That's how that's read. Y is equal to log base a of x. This is a lowercase l, a lowercase g, a lowercase l, a lowercase o, and a lowercase g. The a is what we call a subscript. It's below it. And then the x is back on line with the l, o, and g. And what the logarithm allows us to do is that y is equal to log base a of x, if and only if x is equal to a to the y. It's a way for us to solve that exponential equation for y. I'll say that what it was. Oh, we'll come back to it. Sure. The domain of a logarithmic function. Well, we know that the base can't be 1 and it has to be greater than 0. But whenever you're taking the logarithm of this x, needs to be greater than 0. That is going to be our domain problems that we will see. So whatever you're taking a logarithm of has to be greater than 0. Has to be positive. Leave it at that. Okay, and so when people were working with these logarithms, they got tired of trying to write a little base all the time. And since we use a base 10 number system, they said, well, let's just, anytime you see log without a base, we'll assume it's 10. So if you have just log of x, that's the same thing as log base 10 of x. And that's called the common logarithm. So if there's no base on your logarithm, it's assumed to be 10. And there's another special type of logarithm, and that's a logarithm with base e. Remember Euler's number that we talked about? Log base e of x will be written as ln of x. That's lowercase l, lowercase n of x. And that's referred to as the natural log, the natural logarithm. I'll say ln a lot. It's the natural logarithm. It's an L and an N. Every semester I have someone that goes, it's not working for me when I type it in. It's because they're typing in I's. So don't do that. L and an N. All right, so we know about its relationship with exponentials, but how do we go back and forth between the two? Well, there's this neat little circle thing. Someone called it the magic circle one time. I've never heard that before. Well, I heard it, but I'd never heard of it before then. If you have 5 raised to the x is equal to 125, the base is going to remain the same. In this exponential equation, our base is 5. That's still going to be our base of our logarithm here, okay? But what we're going to do is say log of base 5, draw my circle, of 125 is equal to x. So we had we had 3 to the x is equal to 27. It would be log base 3 of 27 is equal to x. And that's how you switch it to and from. Well, I guess from exponential to logarithmic. We haven't figured out the other one yet, but we'll talk about that later. Any questions on that? Okay, we got a few to try, I believe. Yep. I'll do the first one, and I'll let y'all try the other one. So if you have 1.2 raised to the 3rd power is equal to m, it means it's going to be log base 1.2 of m is equal to 3. Any questions on that? All right, y'all try the next piece. So you have e raised to the b is equal to 9. A raised to the 4th is equal to 24. I'm going to write those as logarithmic equations. They say logarithmic statements, but it's an equation. Anybody still doing them? All right, so for B, what's the base for B? E. So we're gonna have log base. Log base E of 9 is equal to B, which means we can rewrite that now as what? Do I know?
Ln.
Natural log or ln of 9 is equal to B. Since it's log base E, log base Euler's number, we can write it as a natural logarithm of 9. I really think the reason they did that is because it's easier to write than having to write the bases all the time. Base E and base 10 are used quite often. I imagine it's not fun doing subscripts on a typewriter. All right. And C, it's going to be log base A of 24 is equal to 4. And that one we can't change anything. It's just log base A. I'm going to do that. Any questions on C? Or B? I don't think I asked that question. All right. Here we go next. All right, so let's figure out how to go the other way. If you have log base 5 of 125 is equal to x, you basically do the same little circle thing. Your base is going to be 5 here. It's going to be 5 raised to that power. So 5 raised to the x power is equal to 125. So it's going to be 5 to the x is equal to 125. If we had the natural log of 17 is equal to x. And we want to switch that to exponential form. First thing we want to do, well, what is my base? Well, it's log base E. The 17 is equal to x. And so it's going to be E raised to the x is equal to 17. That's going to be my exponential form. First one, you got log base A of 4 is equal to 5. So that means it's going to be A raised to the 5th power is equal to 4. Any questions on that one? For B, they already changed. They made it log base E of B is equal to -3. So that means it's going to be E raised to the -3rd power is equal to B. Any questions on that one? And the last one, you got log base 3, 5 is equal to C. So that means it's going to be base 3 raised to the C is equal to 5. So 3 to C is equal to 5. Any questions on that? All right, so if someone asked you, I don't know who would ask you this, but what if they said, what is log base 5, 125? You think we can figure that out?
Yeah.
How would you figure it out?
And then you just like figure out what 5 raised to something is equal to 5.
Yeah, so we can use what we learned. Like if we have log base 5, why did that switch my marker type? Of 125, and we set it equal to some variable, x, let's say. And you use whatever variable you want, I just like x. And we switch that to exponential form, it will be 5 to the x is equal to 125. And if we think about getting those in the same base, 125 is 5 raised to the what power? To the third power. Good. And so that means, rewrite that. And so that means that x would have to equal 3. That means that log base 5 of 125 is 3. So you're right. What it's saying is, what power do I have to raise 5 to get 125? So basically it's like this. That is what that logarithm is at. Because it's the inverse function of exponentials, of an exponential function. Instead of you plugging in the exponent and you getting what the value is, you have the value and you're trying to figure out what exponent gets you. So that is what logarithms are asking. So you can figure them out this way, and a lot of people like doing it that way. But if you understand that this is asking you, what power do I need to raise this base to get this number, you can also figure it out that way. Any questions on that? All right. So that being said, let's talk about going to the right page first. There we go. Let's talk about some properties of logarithms. Now, there are a lot more properties to logarithms than I'm going to cover in this class. 3.I, there we go. But we're only going to kind of brush the surface of logarithms a bit. I mean, you'll get a good understanding of them, but there are more advanced things that if you go on to take like 106, you'll probably learn them there. And I teach 106, so I know they go over it in there. And that's the only class I think I teach. It might be 108 even too. But you may learn more about them then. But this is just to kind of give you a more overview of it. And so the first one is if you have log base A of 1. Doesn't matter what the base is. That's why we're just putting A. That's always going to equal some value. Anybody knows what that is?
0.
How do you know that? Do you just know it?
Well, if you raise anything to 0, then you get 1.
Yep, exactly. So if I want to know what power do I need to raise something to get 1, it's going to be 0. There's one exception to that, and that's if A is 1. But we said that A couldn't be 1. So that's why we don't have to work with it. Any questions on that? All right. What if you were given log base A of A? That would be 1. It's asking what power do I need to raise A to be itself? It's 1. Be 1. Any questions on that? So that leads to 2 more properties. If you have the natural log of E, what is that going to be? What's the base there? It's E. So you're saying, what power do I need to raise E to get E? 1 once again. And we can do the same thing for our common logarithm. If it's log of 10, it's an understood base of 10. So that's just going to be 1 as well. So those kind of come from this one. These kind of, I didn't want red. I wanted orange or yellow, whatever color it is. So that kind of leads to those. And We're not gonna do those. It's not. I wish we could spend like a month on logarithms. If you have log, no, I'm just gonna rewrite the whole thing. If you have log base a of a raised to the n, what will that be? You're asking yourself, what power do I need to raise a to end up with a to the n? I'll write it out. Maybe it'll spark again. So you're saying, what power do I need to raise a to? The question mark. No. That way it equals a raised to the n. N. Yep. So if you have a log of some base is equal to that base raised to a power, that's just going to equal that power. So if someone asks you, what's log of 5? 125? That's the same thing as log base 5 of 5 to the third, right? So what power do I need to raise 5? Get 5 to the third. That's going to be 3. So just like we did before, you can use that to solve them as well. Any questions on that? And let's talk about one more thing, I guess. What if we did log base, let's do 3 of 0. Log base 3 of 0. What power do I need to raise 3 to get a 0? 3 to the 1 was going to be what? 3. Yeah. 3 to the 0 is going to be what? 1. Is there anything I can raise 3 to get 0? No, so this is not defined. And that comes away from the point where we said that log base a of x has to be greater than 0, right? So what you're taking the logarithm of, it has to be positive. So if it's 0 or negative, it's not defined. And there was one more I wanted to do. Any questions on that one? Before? And let's stick with 3. It's gonna be log base 3 of 1/3. Can we do that first off? And if we can, what's gonna be the answer? So we can do it with this? Yeah. It is defined, I'll tell you that much. Because it is greater than 0, 1/3 is greater than 0. -1, right? If I want to make 3, raise it to some power and get 1/3, I'm going to use a -1. So that's going to be -1. And so,
I'll get into the rules.
Yep. So basically all those rules you learn from exponential functions apply for logarithms. So that's what I'm saying. There's a lot more properties we did go over, but this is about as far as we're going to go. So if you had log base 3 of 1/9, what would that be? -2. Good. Good. Any questions on that? that? Yes. And then we'll go to that. So this way we can get through these. I mean, this is kind of using the stuff we just talked about. If we want to find the exact values, remember what we're trying to figure out is what power do we need to raise at base to get that value. So if I have log base 2 of 16, what is that going to be? You're asking yourself, what do I need to raise 2 to get 16? Is it 4? Yeah, I believe so. So this would equal 4. Now, if you want to make it into an exponential equation, you can. That's totally fine. That's how I used to teach. But, I don't know. It feels more complicated. Any questions on that? Oh, we kind of did this one already. If you have a log base 3 of 1 over 27, what power do I need to raise 3 to? You get 1 over 27. Negative 3. Yep. Any questions on those? And I think I got 2 for y'all to try. Oh, geez, really? Oh, let me bring up the other one. I don't know why I put it all the way down there. Okay. So give these 2 a shot. You got log base 7 of 343 and log base 11 of 1 over 1,331. So what did I get for log base 7 of 343? 3. We need to raise 7 to the 3rd power. Get 343. The log base 7 of 343 will be 3. And what did I get for log base 11 of 1 over 1,331? That was negative 3. Because if you raise 11 to the negative 3rd power, you're going to flip it over, be 1 over 11 to the 3rd, which is 1 over 1,331.